Everyone, I welcome you all to my channel Wins Academy for Competitive Exams. In this video, we are going to see the classification of systems and some problems that are asked in the competitive exams. Our learning objectives are introduction about systems, then classification of systems. There are 5 classifications of systems. The first one is static and dynamic system, second one causal and non-causal system, third one is linear and non-linear systems, fourth one time variant and time invariant systems, and the fifth one is stable and unstable systems. Then some example problems with step-by-step solutions. Also problems that are asked in the competitive exams. So first let us see the introduction about a system. Already we have seen this system in detail in the previous video. If you have any doubt, you can clarify it. The link is given in the description box. So now we are going to recall it. So system is used for processing the signals. So here we are having continuous time system and discrete time system. Always remember, continuous time system will process only continuous time signals, that is analog signals, and discrete time system will process only the discrete time signals. Also, continuous time system will give continuous time signal as the output. Discrete time system will give discrete time signal as the output. So here x of t, x of n is the input and y of t, y of n is the output. Also here we have to see what is present input, past input and future input, right? So x of t, t means it is called as present input. Yes, x of t minus 1. T minus 1 means it is past input. And x of t plus 1, it means it is future input. So y of t, t is the present value. Here it also depends on the same t. So that only we are saying it is present input. Here t, t minus 1. So it is the past value. So we are saying it is past input. Here t, here we are having t plus 1. So it is future value. So it is called as future input. So now we are going to see what is meant by static and dynamic system. So static system means it is memoryless. Why we are saying it is memoryless means here the output of the system depends only on the present input. It does not depend on the previous input or the future inputs. So it depends only on the present input. So that only we are saying it is memoryless. It does not have any memory. Right, for example, y of t equal to x square of t. This is for continuous time. Then for discrete time, y of n is equal to n into x of n. So when t is equal to 0, what happens? Y of 0 equal to x square of 0. That means the output at time t equal to 0, we are having the input at the same time t equal to 0. When t equal to 1, y of 1 is equal to x square of 1. So the output at any time instant depends on the present values of the input. It does not depend on past or future values of input. The best example is calling bell. So when we give an input, it will give an output. It does not store any the previous value or the future values. So next we are going to see what is meant by dynamic system. So dynamic system means here the output depends on the past or future values of the input. Example, y of t equal to dx of t divided by dt. This is for continuous time, and for discrete time y of n is equal to x of n minus 1. Now here substitute n is equal to 0. So y of 0 is equal to x of minus 1. Y of 0 is the present output and x of minus 1 is the past input. So here present output value depends on the past input. So it is called as dynamic system. Another one best example is student performance. Based on the past exams, the marks will be allocated based on the previous exams. So now we are going to see an example in static and dynamic system. Check whether the following system is static or not. Given y of t equal to 2x of t plus 3 into x of t minus 3. So already we have seen what is static system and what is dynamic system. Static system means here the output depends on the present input, and dynamic system means output depends on the past or future inputs. So first we have to substitute t equal to 0 in the given equation. So if we substitute t is equal to 0, we will be getting y of 0 is equal to 2 into x of 0 plus 3 into x of minus 3. So here x of 0, this is the present input, and x of minus 3 is the past input. So from this itself we can say it is a dynamic system. Either we can substitute t is equal to 0, otherwise t is equal to minus 1 or t is equal to 1. Anything we can do it. Next we are going to see causal and non-causal systems. Causal system is otherwise called as anticipative systems. Here the output at any time instant depends on the present and past inputs but not on the future inputs. Example, y of t equal to x of t plus x of t minus 1. This is for continuous time case. And y of n is equal to x of n plus x of n minus 1. This is for discrete time case. Now, for continuous time case, substitute t equal to 0. So, what will get y of 0 equal to x of 0 plus x of minus 1. Here, x of 0 is the present input and x of minus 1 is the past input. Let us substitute another value. When t is equal to 5, y of 5 is equal to x of 5 plus x of 4. Here also 5 is the present value. So x of 5 is the present input and x of 4 is the previous value. Therefore it is called as past input. So here also output at any time instant depends on the present input as well as past input. So it is a best example for causal system. Another one example is end semester result based on the previous internal exam marks and the current exam. So previous internal exam mark is the past input and the current exam is the present input. So the next one is non-causal system. Non-causal systems are also called as non-realizable system. Why we are saying it is non-realizable means here the output depends on the future values of the inputs. So future values of the inputs means we don't know what is the value. We have to guess the value. So it cannot be realized in practical. So that only we are saying it is non-causal systems or non-realizable systems. Example, y of t equal to x of t plus 3 plus x square of t. So when t equal to 0, what is y of 0? Y of 0 equal to x of 3 plus x square of 0. So here x square of 0, this is the present input and x of 3 is the future input. So here the output depends on the future input value. So it is called as non-causal system. Another example, when t is equal to minus 1, you will be getting y of minus 1 is equal to x of 2 plus x square of minus 1. So minus 1, this is the present input value and 2 is the future input value. So let us see an example on causal and non-causal system. So check whether the following system is causal or not. Y of t equal to x square of t plus x of t minus 2. So already we have seen causal means the output depends on the present or past inputs, but non-causal means output depends only on the future inputs. So first step, substitute t is equal to 0. So if you are substituting t is equal to 0, y of 0 equal to x square of 0 plus x of minus 2. So x square of 0, this is the present input and x of minus 2 is the past input. So from this itself we can say it is a causal system. We can check by substituting other values also. Substitute t is equal to minus 1 as well as while substituting t is equal to plus 1. You will be getting y of 1 is equal to x square of 1 plus x of minus 1. So here x of minus 1 is the past input value, x square of 1 is the present input value. So the system is a causal system. The next one is linear and non-linear system. So linear system always satisfies superposition principle. So superposition principle means weighted sum of the input signal is equal to weighted sum of the outputs of the system to each of the individual input signals. That is t of a into x1 of t plus b into x2 of t is equal to a into t of, that is a function of x1 of t plus b into t of x2 of t. So individually we have to perform the calculation and we have to add and we have to check whether it is equal to the LHS. So for discrete time case, t of a into x1 of n plus b into x2 of n is equal to a into t of x1 of n plus b into t of x2 of n. So if a system does not satisfy the superposition principle means then it is called as nonlinear system. So this is not equal to the RHS. So next we are going to see an example problem on linear and nonlinear system. Check whether the following system is linear or not. Y of n is equal to 2 into x of n plus 1 by x of n minus 1. So if it is a linear system, then it should satisfy this condition, that is superposition principle. T of a into x1 of n plus b into x2 of n is equal to a into t of x1 of n plus b into t of x2 of n. So first we are taking the right hand side. So here we are having two terms, that is for x1 input and the second term is for x2 input. So first we are going to see for x1 input. So instead of x, replace it by x1. So you will be getting this equation. We have to multiply by a. So you will be getting 2a x1 of n plus a divided by x1 of n minus 1. Next, for the second input, x2 of n. 2 into x2 of n plus 1 by x2 into n minus 1. So here we have to multiply by b. So you will be getting this answer. Now we have to add both these terms. Then only you will be getting the RHS. So while adding both the terms, you will be getting the equation like this. So keep it as equation 1. Now we have to take the LHS. So LHS a into x1 of n plus b into x2 of n. So the total x value is replaced by both x1 of n and x2 of n. So t of a into x1 of n plus b into x2 of n is equal to 2 into, here we are having x of n. Instead of x of n, we have to substitute both the terms. A into x1 of n plus b into x2 of n plus 1 divided by a into x1 of n minus 1 plus b into x2 of n minus 1. Now we have to check whether equation 1 and 2 are equal. Here it is not equal. So the answer is, it is a non-linear system. The next type is time variant and time invariant systems. So from the name itself we can understand time variant. Time variant means time varying. Time invariant means time does not vary. So time invariant system means the input output characteristics do not change with time. So here the output is delayed by time capital T. The input also delayed by the time capital T. This is for continuous time and this is for discrete time. Time invariant system means the input output characteristics change with time. So here if it is delayed by time t, it will be not equal to that input delay. So it is called as time invariant systems. So now we are going to see an example for time variant and invariant systems. Check whether the following system is time variant or invariant. Y of t equal to t into x of t. So we know the condition. Time invariant means this is equivalent. That is, if they are delaying any value at the input side, the same will be delayed at the output also. It is called as time invariant. Time variant means there will be variation in the delay. So first step, output due to the delayed input. First we have to calculate the output due to the delayed input. Input is delayed. So you will be getting y of t equal to t into x of t minus capital T. Next, we have to delay output by capital T. So y of t minus t is equal to t minus t into x of t minus t. Now we have to compare equation 1 and 2. It is not equal. So the answer is, it is a time variant system. So the next classification of system is stable and unstable system. So stable system means it is represented using Bibo stability, that is bounded input, bounded output. For every bounded input signal, the system will produce a bounded output signal. Then it is called as stable system. So integral minus infinity infinity modulus of h of t dt is less than infinity. This is the condition for stability. That means it should have a finite value. If it goes for infinite value, then it is an unstable system. So here also summation, this is for discrete time case. Summation n is equal to minus infinity infinity, modulus of h of n is less than infinity. If this condition is not satisfied, then it is called as unstable system. So next we are going to see an example problem for stable and unstable system. Check whether the following system is stable or not. Y of t equal to t into x of t. We know a system is stable means it should satisfy the Bibot stability condition. That is, for bounded input it should produce bounded output. So an easiest method to check the stability is we have to assume the input signal as the step input, and we have to apply for the system, and we have to check whether the output is bounded or not. So here assume the input to be a step input, that is u of t. So already we have seen what is a step input signal. If you have any doubt, you can refer the link given in the description box. So x of t is equal to u of t. So here the input is assumed as the unit step input. So x of t is equal to u of t. Instead of x of t, you have to substitute as u of t. So you will be getting y of t equal to t into u of t. So now if you substitute t is equal to 1, what is the answer? T is equal to 1 means 1 into u of t. U of t value will be equal to 1 for 0 to infinity. That already we know. So 1 into u of t. Then again y of 1 is equal to 1, y of 2. If you substitute t is equal to 2, what is the y of 2 equal to 2? Y of 3 is equal to 3. Y of 4 is equal to 4. Like that it goes on. So we will be getting an unbounded output. So the system is unstable system. So next we are going to see some problems that are asked in the competitive exams. First problem. The following system y of t equal to x of t cos 100 pi t is. So we have to check whether it is dynamic, linear, time variant, causal or non-causal, or stable or unstable. So first we are going to check whether it is static or dynamic. We know static means output depends only on the present input, and dynamic means output depends on the past or future inputs. So substitute t is equal to 0. So y of 0 is equal to x of 0 cos 0. If you are substituting t is equal to 1, y of 1 is equal to x of 1 cos 100 pi. So from this it is clear output at any time instant depends on the present time only. So it is called as static system. Next we are going to check for time variant or invariant. It is more easier than checking the linear and non-linear systems. So y of t minus capital T is equal to or not equal to t of x of t minus t. This we are going to check. So first we are going to delay the output by capital T. So y of t minus t is equal to x of t minus t into cos 100 pi of t minus capital T. Then we have to delay the input alone, x of t minus t. So that is equal to x of t minus t into cos 100 pi t. So can you able to follow? Because here we are delaying only the input, here we are delaying the output. So if you are delaying the output means all the term, wherever t comes, t is replaced by t minus capital T. But while delaying the input, only the term inside the x will be delayed, right? So now these two are not equal. So it is time variant. So option B is the right answer. So next problem. The signal x of n is equal to cos 2 pi by 3 into u of n is. So u of n we know its limit from 0 to infinity. That means it has positive sided sequence. So it is causal signal. It depends only on the present or past input values. Also u of n unit step signal is an aperiodic signal. Aperiodic signal means it does not repeat periodically. We will be having a constant value from 0 to infinity. So it is an aperiodic signal. So option A is the right answer. So next, the principle of superposition is applicable to, we know, superposition principle means it relates only the linear system. So option A is the right answer. So the next problem is the given discrete time system y of n is equal to x of minus n plus 2. So we have to check. So first substitute n is equal to 0. So while substituting n is equal to 0, you will be getting y of 0 equal to x of 2. So the present time instant, it depends on the future input value. So it is called as dynamic system. Next, we have to check whether it is causal or not. So substitute y of minus 1. That means n is equal to minus 1. So y of minus 1 is equal to x of 3. Here it depends on the future input value. Next, substitute n is equal to 2. So y of 2 is equal to x of 0. So it depends on the past input value. So it is non-causal system. Then here we have to check the stability. So for checking the stability, we have to assume the input signal as unit step input. So x of n is equal to u of n. That means u of minus n plus 2. So again we know it is a stable signal. U of minus n plus 2 is a stable signal. So the output is a stable output. So option A is the right answer. So the next problem is the system represented by the input-output relationship y of t is equal to integral minus infinity to phi t x of tau into d tau. We have to check whether it is linear or non-linear, causal or non-causal. First, we are going to see whether it is linear or non-linear system. So already we have seen the condition for linear and non-linear system. Linear means t of a into x1 of n plus b into x2 of n is equal to a into t of x1 of n plus b into t of x2 of n. So this is our question. For x1 tau of input, you will be getting y1 of t is equal to integral minus infinity to phi t x1 of tau into d tau. For x2 of tau, you will be getting y2 of t is equal to integral minus infinity to phi t x2 of tau into d tau. Now we have to add x1 of tau plus x2 of tau. So here y3 of t is equal to integral minus infinity to phi t x1 of tau plus x2 of tau into d tau. Now y3 of t is equivalent to y1 of t plus y2 of t. So we can say the system is a linear system. Next, we have to check whether it is causal or non-causal system. So here we are assuming, for simplification, we are assuming z of tau is equal to integral of x of tau into d tau. Now, when t is equal to 0, what is the value of y of 0? Equal to integral minus infinity to 0 because t is equal to 0. So, minus infinity to 0 x of tau into d tau. This can be written as upper limit minus lower limit. So, z of 0 minus z of minus infinity. So, present output depends on the present input as well as past input value. Similarly, t is equal to 1, y of 1 is equal to integral minus infinity to x of tau into d tau. So that is equal to z of 2 minus z of minus infinity. That is upper limit minus lower limit. So here the output depends on the future values. So it is called as non-causal. This is the present value. Here 2 is the future value. So it is non-causal. So option B is the right answer. Now we have come to the end of the session. I hope you all have understood. If you like this video, kindly subscribe it and press the bell button so that you can get the notifications regarding my future videos. Thank you.